In this video, we are going to discuss and understand about the next type of integration, that is definite integral. Okay, so we are going to understand about the next one, that is definite integral. All right, now this is the next part of the integration chapter. Now, in the previous part, we had discussed about indefinite integrals. When I say previous part, not the previous video, the entire thing. We had discussed about the indefinite integrals, right? So, where a basic part is you integrate and then you are going to get a value, right? Now, we did not discuss what is the meaning of that indefinite integral, correct? Now, here in this video, we are going to understand the meaning of a definite integral, or rather the meaning of integration. Okay, that's why we start this particular concept with the concept of fundamental theorem of calculus. Okay, so when we say fundamental theorem of calculus, what is the meaning of that? What does it represent? We're going to look into that one. All right, so first and foremost, when we talk about definite integral, the integral has a limit. From one point to one point, there is going to be a particular limit, and we are going to consider this limit whenever we are integrating. Okay, so very first thing what we have, assume that you are going to have a particular some graph. Okay, some function is there. Say you have y-axis and you have x-axis. Now here some function is there. Assume that this is the function, something like this. Now the function is given by y is equal to f of x, the defined function, and this defined function is from R to R. Fair enough. Now we are going to consider 2 points, say a and b. That means here, let's say we have one function. Say this point is a, this is gonna be f of a, and from here, say b, this is f of b. And we need to calculate the area under this particular curve. Okay, so let me repeat. We are trying to calculate the area. So in this case, we are trying to find this area. Clear? To calculate that area, what we do is we are going to take a very simple logic. That is, we are going to take very small strips. Fair enough? That means here, if you look at it, so this is one, this is one. See, we have a very small rectangular strip. Because you keep adding those rectangles, you are going to get the entire curve. All right. Now, what we have is, in this case, this length, what we have is dx. Right. Now, the indefinite integral used to give us some particular function when you integrate, correct? Whereas definite integral is going to give you the area under the curve of the function, whatever function you are going to take. That means in this case, we have the area of x. So this is given by the integral capital F of x value. Alright, that means f of x is nothing but integral f of x dx, but it is from which point to which point? It goes from point A to point B. Understood? So the meaning of this particular definite integral, you can say that this point is A, say this is B, C, and say this is D. All right. Now here the area of A, B, C, D, A, that is nothing but integral of f of x dx from A to B. Now this is what we call as definite integral. In the sense, whenever we need area of any curve with respect to x-axis, okay, then we take integration f of x dx. Fair enough? Now, the next thing what we know is that since you have this value, whatever area you are going to get, area cannot have plus c value, correct? So how are we going to integrate this one? What we are going to do for this particular part, how we are going to evaluate this definite integral. We'll look into all these things in the next video.